Good morning. Today we are going to discuss another important lecture in computer architecture and organization, which is nothing but interface circuits. Listen, I/O interface consists of a circuitry required to connect an input-output device to a computer bus. In previous classes, I told you that whenever the data will be transferred from one device to another device in a computer, we require the buses. With the help of bus, the data will be transferred from one place to another place. Similarly, here I am going to discuss about input-output interface circuit. Whenever the computer wants to communicate with the input-output devices, they cannot directly communicate the input-output devices. They can be communicate the input-output devices with the help of input-output interface circuit. Okay, so the input-output interface circuitry is required to connect the input-output devices to your computer bus. They cannot directly connect it to the bus. With the help of input-output circuitry only, they will be connected. The input-output devices are connected to the bus. Now, for an example, see my friends, this is my bus, and here we are having the processor, and here we are having the memory, and here this is nothing but the interface circuit. With the help of the interface circuit, we are going to connect the input-output devices to the system. See, for the processor and memory, we doesn't require any interface circuits to interconnect to the system bus. Whereas for the I/O devices, whenever we want to interface those I/O devices to your computer bus, we should require the interface circuitry. See, for this interface circuit, we have two ends. One is this side and the other one is this side. One side of the interface which connects the computer bus. See, this side will be connected to the bus. Yes or no? And this side will be connected to the input-output. This side will be connected to the input-output device. The input-output device side of the interface circuit is known as port. This side is known as port. So, ports are classified into two types. What are they? One is parallel port and the other one is serial port. Now, coming to this case, parallel port. Why we require parallel port as well as why we require the serial port to transfer the data from input-output devices to the computer bus? Whenever we are using the parallel port, we can be transfer the large amount of the data from the input-output devices to the computer bus. For an example, if I want to 32-bit of data from input-output devices to the system bus, then I may require 32 lines to transfer the data from input-output devices to the system bus. Similarly, if I want to transfer an 8-bit data to the system bus, and if I want to transfer the data serially, that is bit by bit, at that time I require a serial port. So, ports are of two types. One is parallel port and the other one is serial port. Both the ports are used for transfer the data only, but in different manners. Whenever we transfer the data serially, the data transfer rate is low when compared with the parallel. Now, parallel port transfer data in the form of number of bits. Normally 8 or 16 from the device end. That's only I told you that if the input-output devices wants to transfer 32-bit of data, then it requires 32 lines. Similarly, here it is an 8 or 16, then it requires 8 lines or it may require 16 lines. Serial port transfers as well as the received data bit by bit, not at a time. Serial port transmission, it cannot receive the total data at a time. It may receive the data one after another. Conversion from the parallel port to serial as well as serial port to parallel, we require the conversion circuit that is inbuilt in the interface circuit. Okay, parallel port uses multiple pin connector between the device and the processor. See my friends, here this is the processor and this is my bus, and by using the input output interface circuit, I am going to interface the input output device. Okay, so look at this. This is the interface circuit. One end of the interface circuit will be towards the bus, and the other end of the interface circuit is towards the input output device. This side is known as port side. Okay, see, parallel port uses the multiple pin connector between the device and the processor. Suppose if the user wants to transfer the data parallelly from input output devices to the processor, at that time must and he should require the parallel port. Okay, at that time this parallel port uses a multiple pin. That's what I told you. Whenever we transfer the data parallelly, we require more number of interconnection lines. Okay, now coming to the case, a cable with as many wires as the number of bits transferred simultaneously, hence it is suitable for the device that are physically close to the computer. Just now only I told you that whenever we transfer the data parallelly, suppose if I want to transfer the 32-bit of data, then I may require 32 lines. So whatever the data you want to transfer, that many number of cables you require for the transferring of the data. Okay, so as many wires. Okay, as many wires. A cable with as many wires as the number of bits. If the number of bits is 8, then we require 8 wires. If the number of bits is 16, then you may require 16 wires. And hence it is suitable for the device that are very much closer to the device. Okay, so whenever I want to transfer the information from one place to another place, if the destination and the source are very much nearer to each other, then I may use the parallel communication. If the destination and the source are far away to each other, at that time I may be used the serial communication to transfer the data because of cost reduction. If they are very much nearer to each other, then even if I may use the more number of cables for transferring the data, the length of the cables are small. So obviously the cost is also small. If I want to transfer the longer distances, then parallelly, if I may require the large length of cables, then the cost will be increases. So here also a cable with as many wires as the number of bits transferred simultaneously, hence it is suitable for the device that are physically close to each other. Okay, serial port uses a single pin connector. Even if you want to transfer 100 number of bits, 1000 number of bits, you can be transferred bit by bit only in case of serial port communication. So we are using only the single pin connector between the devices that are very much longer to each other. Okay, so now I am going to explain how the parallel port communication is performed and how the serial port communication is performed. First I am going to explain the parallel port communication. Okay, now see this one. Keyboard is connected to the processor. Here I am using the parallel port. Now I am assuming my processor is a 32-bit processor. That means at a time it is capable of accessing 32-bit of data. and now this totally is treated as keyboard. Okay, here I am going to explain the read operation. Why? Because we are all very well known that the keyboard is the input device and it can be transferred the data to the processor. So this total circuit here I am treating it as a keyboard circuit. Okay. Now whenever the processor wants to communicate with the other devices, first of all it has to assign the address to that device. Whenever we are going to assign the address to the input output device, there are two schemes we are using in this case. One is memory mapped IO scheme, input output scheme, and the second one is IO mapped scheme. What is the difference between memory mapped and IO mapped scheme? How we have to use these two schemes for assigning the address to the input output devices. In case of memory mapped input output scheme, both the memory as well as input output are placed in the same memory space. Here the memory as well as input output space are separated to each other. So the same instructions we are going to be used for memory data as well as input output data. Here if I want to use the move instruction to transfer the data, okay, so that will be suitable for the data which is stored in the memory as well as that will be stored the data which is suitable which is stored in the input output space also. But here in case of input output mapped scheme, we may not use the same type of instructions for accessing the data. For memory we may use the move. For input output data we may be using the instruction in and out. So while you are going to assign the address, you may be assigned you may be assigned the address to the input output devices. You may be used any one of these schemes. But here I am using the memory mapped input output scheme. So for accessing the data, I may be used the same instructions. If the data is stored in the memory space or if the data is stored in the input output memory space, I may be used the same set of instructions. Now listen clearly. Whenever you press any character on the keyboard, then the equivalent ASCII character will be transferred to the processor. Okay, ASCII character, this will be transferred to the processor. Okay, ASCII, American Standard Code for Information Interchange. This is also in the binary format, but for each and every character representation, we may require 7 or 9 bits, including the parity bit also. Okay, here we are having one more circuit, which is nothing but encoder and decoder circuit, which is used to transfer the data from the keyboard to the interface circuit. Okay, so next we are having the debound circuit. What is the debound circuit used? When there are keys in the keyboard, whenever you press the key, then the suppression of the bouncing will be eliminated by using this debound circuit. Otherwise, the same character will be repeatedly printed on the repeatedly stored in the interface circuit resistor. So we must use the debound circuit also. Okay. Now see this one. Here it is a processor and it is a 32-bit processor. That means it is capable of accessing 32-bit of data at a time. Now listen. Here we are going to explain. I am going to explain the read operation concept. Okay, even if it is a read operation or even it is a write operation, initially the processor has to assign the address to the input output device. Here we are using the input device, that is the keyboard. First step is the processor has to assign the address to the keyboard. This is the first step we are going to be used. Now see my friends, here we are using the so many number of control signals also. And one more assumption we have to consider for interfacing parallelly keyboard to the processor, that is asynchronous protocol. While you are going to transfer the data, we are going to be used asynchronous protocol. By using this protocol, we are going to transfer the data. Okay. Next, this is the first step. In this case, the processor has to assign the address to the slave device. Okay. What is the second step we need to apply? The second step is what type of operation we are going to be performed. That means the control signal. Which type of control signal we have to use? Which is nothing but here we are using the read operation. So R by W bar should be equal to 1. There is no bar over R. So R is equal to 1. Okay. That means this is the read operation. Okay. Next, what we want to do? Now, what is the next step we have to perform? First, the processor assigns the address to the input device. Next step is it can be assigned the read operation. Okay, and the next one is it has to processor has to assign the master ready signal and informs to the slave device that the processor is ready to participate. So this is the task that we need to perform. Once the processor assigns the master ready signal, okay, then the slave identifies that the master is ready to participate in the data transfer. Okay, this is the third step. Next, once the input device is identified, the master is participating in the data transfer, then the input device has to place the data on the data bus. Okay, this is the fourth step we are going to be performed. Okay, now the input device is placing the data on the data bus and it informs to the processor with the help of a valid signal. This is the step number 5. And that means whatever the data the input device placed on the data bus, which is a valid data. Okay, and then next, the input device asserts with the help of the slave ready signal, I finished my operation. Okay, so that the processor identifies the data is placed on the data bus. Okay, and the processor recognized it with the help of slave ready signal. See my friends, here if you observe the data lines, there are multiple number of data lines. That is parallel operation is going to be performed. Okay, so these are the steps we need to perform one after another while we are going to interface keyboard parallelly to the processor. Okay, next, once a valid data will be valid data is placed on the data bus, then the interface circuit contains so many number of resistors. It may contains data in resistor, it may contains data out resistor, serial in status resistor, S in status in resistor and S out resistors, like that. It may contain several types of resistors. But here we are discussing about the input operation. So we required data in resistor, okay, as well as status in resistor. So whatever the data will be placed on the data bus, that will be transferred to the interface circuit. Why? Because the data transfer in between the processor and the input output device is with the help of interface circuit. So the data will be transferred to the data in the buffer resistor. Okay. So see my friends, the processor, how it can be recognized whether the data is entered into the data in register or not. That can be identified with the help of status register, single bit status register, SIN. Whenever SIN is equal to 1, then the processor identifies there is the data present in the data in buffer register. So from that, the processor receives the data into the processor unit. Okay, this is your step number 7. Okay, so once the data is entered into the processor, then immediately the SIN bit will become 0. It identifies that there is no data will be present in the data in the buffer register. Okay, these are the steps we are going to follow while we are going to perform the parallel interfacing to the processor. Okay, next one is internal structure of interface circuit. This is very important in case of examination point of view. See my dear friends, here I am going to consider 32-bit address. Out of those 32 address lines, I am going to be used only the 31 lines, A1 to A31, and these lines are used for assigning the address. Okay, and this is my A0 line. Okay, and this A0 line is used whether I may read the data or that A0 line is used whether I may read the status. For that I may use this A0 line. Out of these 32 lines, only 31 lines will be used for the address, and A0 line will be used to distinguish whether we are going to read the status or whether we are going to receive the data. Okay, and here we are using the asynchronous data transfer, so we required some handshaking signals. Here we are using the master ready handshaking signal, Okay, and here I am using one more control signal, which is nothing but read write control signal. Now listen. The internal structure of interface circuit. See this one here. This is the address decoder. Initially, the master places the address on the address lines so that the slave device decode that address. One of the slave device will be recognizing that address. So always I am assuming the address decoder output is equal to 1. Once the master places the address on the address lines, what is the second step we are going to be used? We are going to be used the type of operation we are going to be performed. Here I am explaining the input operation, which is nothing but read operation. Input operation means read operation. So R by W bar is equal to 1. So this one is also becomes 1. The same read write signal is also connected to here also. This is the first AND gate. This is the second AND gate. So the read write control bar signal is applied as one of the inputs of the gate, and then master ready signal. Here also I am assuming it as 1. Here also I am assuming it as 1. And the address decoder. This is the line for the address decoder, that will be assumed as 1, and here it is also assumed as 1. Suppose now if I want to receive the data, okay, then that should be depend upon A0 signal. If A0 is equal to 1, then what happened? If A0 is equal to 1, the complement will be applied, so it will become 0. Then here for the second AND gate, the direct input will be applied, then it will become 1. Okay. Now see my dear friends, if one of the input of the AND gate is equal to 0, then obviously the output of the AND gate will be equal to 0. All the inputs of the AND gate will become 1, then this one will become 1. And now see my dear friends, this one will be applied as signal for the tri-state buffer, or they may be treated as drivers also, and this signal will be used as a enable signal for the tri-state buffers. Now see this one. While I am explaining about the keyboard operation, keyboard interface to the processor in parallel operation. First, see my dear friends, the data on the data lines will be transferred to the data in buffer once it is a valid signal. Okay. See, in previous slides I told you that. Go to the previous slide. Here, what I told you, the data from the keyboard is placed on the data bus and informs to the processor with the help of valid signal. If the valid signal is equal to 1, then only the corresponding data which is present in the data bus is valid. So whenever the processor receives the data from the interface circuit, it will be verify all these signals, whether it is the valid data or not. That is also verified by the processor. Okay, now see this one. So here we are getting the output as 0, and here we are getting the output as 1, and this one will be applied as driver input, or this one will be used for the operation of the tri-state buffers. Okay, it will be used as an enable signal, so that whenever the valid signal is equal to 1, then the data which is present in the data in buffer register in the interface circuit is the valid data which sets the status flag. When status flag SN is equal to 1, then that indicates there is the data present in the data in buffer register. Okay, now look at this. Once it is a valid data and these drivers are operating, then whatever the data we are placed in the data in buffer register, that will be received into the processor with the help of these data lines. By using these 8 data lines at a time, the processor is receiving an input data. So the A0 signal is used whether you may receive the data or whether you may only read the status of the data. That can be identified with the help of A0 bit. Yes or no? So in this case, I treated A0 is equal to 1. So here it is 1 and here it is 0. One of the input of the AND gate is equal to 0. Then obviously the output of the AND gate is equal to 0. So here I may not perform the read of status read. I may just perform the receiving the data from data in register to the processor. Okay. Suppose if I want to perform read operation, then what can we do? In case of read operation, okay, this is R by W bar is equal to 1. Say the address equal output will be treated as 1. Master ready signal is equal to 1. These 3 bits are always equal to 1. So 1, 1, 1. Here also 1, 1, 1. Now look at this. In this case, I want to read the status of the data in register. I may not receive the data from the data in register. Just I want to read the status. At that time, I am going to be used A0 bit is equal to 0 instead of 1. So it is 0, then this one will become 1. Instead of 0, it will become 1. And instead of 1, it will become 0. Then what happened? All the inputs of the AND gate will become 1. Then the output of the AND gate will become 1. One of the input of the AND gate is equal to 0. Then the output of the AND gate is also equal to 0. So now see my friends, if it is 0, then there will be no enable of the driver circuits, or there is no enable of the tri-state buffers. So the processor won't read any information from the data in register to the processor. That means it may not receive the data whenever this driver buffers are 0. Okay, now this one will become 1. Okay, and this one will become 0. When one of the input of the OR gate is 0, no problem. If all the inputs of the OR gate is 0, then only the output is equal to 0. When any one of the input is equal to 1, then the output is equal to 1. Then this will be act as an enable signal for the slave ready. Okay, so obviously always the input of the slave ready is equal to 1, then the output is also equal to 1. That means the slave is participating for the data transfer. Okay, see my dear friends, now Sn is equal to 1 and this enable signal is also equal to 1. Then what you are going to do? Now you are going to read the status information on the lines. With this, you are going to read the status information. Okay, so whether the data is present in the data lines or not, that can be identified with the help of this status lines. Okay, this is the internal circuit of the interface circuit. Very, very important. Okay, once again I am telling you in a brief way. See, whenever processor wants to communicate the keyboard, first of all, with the help of these 32 bits, it should be assigned the address to the keyboard. But out of those 32 bits, here we are using only the 31 bits, A1 to A31. So always the output of the address decoder is treated as 1. So this will becomes 1. The same thing will be connected to here, and this is also becomes 1. So next, processor performs read or write operation. Here we are considering the read operation. So R by W bar is equal to 1. Here it is 1, and here also it will becomes 1. And processor informs to the slave devices it is participating in the data transfer. For that, it will be assembling the master ready signal. So master ready is equal to 1, and here also it will be equal to 1. Now we want to read the status or we want to receive the input data from the keyboard to the processor. That will be distinguished with the help of A0 bit. If A0 is equal to 1, then we are going to receive the data from the data in buffer register to the processor. If A0 bit is equal to 0, then we are going to read the status information only. Suppose if I want to receive the data from the data in register to the processor, then A0 is equal to 1. Then this is 1, this is 0, then this is 0. This is 1 and it becomes 1. See my dear friends, the output of the AND gate 2 is 1 and the output of the AND gate 1 is equal to 0. And this output of the AND gate will be act as an enable signal for the tri-state buffers. Tri-state buffer performs 3 operations. This is the enable signal and this is the input and this is the output. When enable signal is equal to 1, then whatever the data present in the input, that will be transferred to the output. If enable signal is equal to 0, then no data will be transferred from the input to the output. So here this one will becomes 1, then it acts as a data transfer, so that the data in register will be received by the processor. Okay, once the data present in the data in buffer register, that should be a valid data and it should be informed to the processor with the help of a valid signal, and this act as a clock and this act as an enable signal for the data in register. Okay, this is the way we are going to explain the internal structure of interface circuit. Next, output device interface circuit. Previous case I told you how we are going to interconnect the keyboard to your processor parallelly. Okay, here I am going to explain how you are sending the data out to the printer parallelly with the help of this output interface circuit. Okay, see See my dear friends, whatever the things we discussed in the previous case, the similar type of operations are also seen in this case also. Okay, now look at this. This is my output device interface circuit. Okay, see, I am assuming the processor is a 32-bit processor. Previous case also I assumed the same thing, and for the assigning of the address out of two schemes, we are going to assume one scheme which is nothing but memory mapped input output scheme for assigning the address to the output device. And one more assumption we are going to be considered is for transferring the data, we are going to be using the asynchronous protocol. Okay, these are the three assumptions we are going to be considered whenever we want to interface processor to the printer parallelly. Okay, now look at this. What are the steps we have to follow whenever we are interfacing the processor to the printer parallelly? The first step is, no doubt, it is an address. First, the processor has to assign the address to the slave devices. Here, the slave device is nothing but the output device, which is nothing but the printer. Whenever processor wants to communicate the data transfer, first of all, it has to assign the address. So, here also the processor has to assign the address to the printer. So, the step one is address. Okay. Next, the second step is nothing but what type of operation we are going to be performed. That is also represented with the help of processor unit. Here we are going to perform the write operation. So R by W bar is equal to 0. If it is equal to 1, then it is a read operation. If it is equal to 0, then it will become a write operation. This is my step number 2. Okay. Once we decided what type of operation we are going to be performed, then we can get a clear idea regarding to this. Whether we are going to perform the read operation or whether we are going to perform the write operation. Okay. Here it is write operation. The next step is we are going to place the data on the data lines. Okay, this is the third step. Here, see my dear friends, the data lines arrow mark should be this side. Why? Because the processor is transferring the data to the printer. It is not receiving the data from the printer. It is transferring the data to the printer. So the direction of the arrow mark should be like this. So this is the step number 3. Next, the step number 4. What is the step number 4? Processor informs to the printer the processor is ready for the data transfer. That should be identified with the help of master ready signal. Okay, so with the help of master ready signal, the printer identifies the processor is ready to participate in the data transfer. Next, see my dear friends, whenever we transfer the data from the processor to the input output devices, we can be transfer the data along with the help of interface circuit. This is my output interface circuit. Not only the bus, we may also use the interface circuit to transfer the data. Okay, so master ready signal is activated. So whenever the master ready signal is activated, then the printer identifies the master is participating in the data transfer. Now what happened? Whatever the data the processor placed on the data bus, that will be transferred to the data out. Okay. Next, see my dear friends, in previous case we have data in register here. Why? Because that is the input operation. But now it is an output operation. So the interface circuit consists of data out register, and this status can be identified with the help of S out pin. Whenever S out is equal to 1, then there is a data present in the data out register. Whenever the data is read by the printer, then the S out will become 0. zero. There is no data present in the data out register. Okay. Now the processor places the data in the data out register. Once the data is placed in the data out register, then S out will becomes 1. Okay, and the processor informs to the slave device that the processor is participating in the data transfer with the help of master ready signal. So data పంపించిన తర్వాత that should be enabled with the help of master ready signal to inform the processor is participating in the data transfer. Once the slave receives this master ready signal, then it receives the data. Okay, that is step number 6. Why? Because before going to receive the data by the printer, it has to verify whether it is the valid data or not. That should be identified with the help of valid signal, which is step number 5. Step number 6 is once it is a valid data, then the printer receives the data from the data out register to the printer. Okay. Once the printer prints the data, then it informs to the processor that the printer is finished its operation with the help of ideal signal. Okay. Once it activates the ideal signal, the printer finishes its operation and it informs to the interface circuit with the help of ideal signal. Once the interface circuits receive this ideal signal and it informs to the processor unit by activating the slave ready signal. Once the processor receives the slave ready signal, then it identifies that the printer is finished its operation. Okay. Whenever the data from the data out register is transferred to printer, then immediately the S out will become 0, so that the processor may transfer another data to the data out register. From that it can be transferred the data to the printer. Okay. These are the steps we have to follow while we are interfacing output to device interface circuit. Now, okay.